Hi, in this video on the BeagleBoard using Python and OpenCV, I continue where I left last time, which is with the colored image and a half black and white image. And by experimenting a little bit, I decided to really do every single step. So with the combined situation, I split that up and write also this to disk, and also I split up in the black and resizing part, so that the resized color and the resized black and white will be separately written to disk, and then we'll see what happens. So I save this, run the code, and we'll see what results I get. This is with the proc 11.1. So that is a little bit resized and relocated as it looks. And here, which is still called combined 11, but you see that I don't have that in the code anymore, so we just skip this for the rest. 12 is still the blurred version, and when going down, that has not changed. No changes here yet, and you see that it is a black and white, but it is a half image, and I still haven't found out why, but we will soon. So let's see about the other files. Cool. 11.1, which are right here. It skips 11. It skips 11.2, so let's see how this will work. See, so this warp-fine with the resized black and white image puts it here, and then the second one using M2, which is the rotation, and this is using the translation, and this one is using the rotation. And the rotation using the translated one. And we continue. The combined 2 and the combined are the same, but that is supposed to be. blur, border, and rotate it back. And so here I should look further into it. So that is the next challenge. And continuing with the problem, I have put some comments in the code to make things clearer. So here I use a translation which uses M, which is above here. Here's M. Then I use a rotation M2, and this is columns divided by 2 and rows divided by 2, and a rotation over 90 degrees. And here we end up with DSD3. Here we blur using DSD3, ending up with DSD4. And here, where something goes wrong, I first define a get rotation matrix with columns times 1.55 and rows times 1.55, while the original rotation is divided by 2. However, as I showed in the previous video, if I multiply this by 2 and this by 2, I get nothing in result. And here I rotate back over 90 degrees. And looking further, I define here M4 translation matrix, and here I use a translation using DSD6, which is here, and this translation matrix. So the only thing that could happen and could go wrong is right here. So let's just try something out. Once again, comment it out, copy, make this 2, make this 2, and see what happens. There's no error, as there shouldn't be. And what should give a different result is proc 14 rotated back. So let's see what has happened. And see, this happens. So let's put this back, save it again, run it, and see I have a much larger part of the image back, which means that columns multiplied by 2 and rows multiplied by 2 is not the correct way. And of course I use the translation by M, which is 0, 100 and 150. Let's try that. So commenting this out. Let's do this times 50, for example. Or maybe minus 50. And this minus 100. And let's see once again. Just experimenting. And now of course I have to look at proc 15. And it goes way up there. And moving everything back. And you see that I have the image translated. Which still does not explain why I have only half an image. Because if I continue, it is clearly visible that is just half the image. And why that goes wrong, I'll have to find out. In the meantime, the code has become clear to everyone, including myself again. So, with some testing and more comments, I still have not found out where the half of the image has gone. Unfortunately. And I guess I have to study the Python manuals again. Anyway, so much for this attempt on getting the thing straight. Thank you for watching, and to be continued.